Okay, in this video, I'm going to run you through the two bones of the forearm. We have the ulna and then the radius. Okay, I'll do the ulna first. It's the more complicated of the two bones. Ulna is always on the little finger side of our forearm. So when we look, remember we have to have our palms facing forward, and if we're going pinky side, that makes it medial. So the ulna is always the medial bone, and then the radius is always going to be the lateral bone. This is one of those bones that I always tell students it's important to understand the left and right, and I'll explain that here as we go through how you can figure that out. Now, the easiest thing I always tell students to do to determine that it's the ulna is to kind of look at it from the side. If you turn it, you kind of see the U shape to it. That U shape is formed by this notch, which I have my finger in right now. That notch is called the trochlear notch, which fits around the trochlea, kind of like what a C would do. The trochlea is a kind of knobbish structure that is on the humerus, and together those form the elbow hinge joint that allows us to flex and extend our elbow. So that is the trochlear notch. Okay, behind and posterior to the trochlear notch is the olecranon or olecranon process, which forms the point of our elbow, and when we put our elbows on the table, that's what we are resting our elbow on. That's what the elbow really is. Okay, so that's the olecranon or olecranon process. The other side of our C, which kind of is shown with my big finger here, I'm rubbing on it, will be called the coronoid process. Now, the nice thing is the coronoid process inserts itself when we flex our elbow into the coronoid fossa of the humerus. Now, don't get it confused with the coracoid process, which is found on the scapula. The olecranon inserts itself into the olecranon fossa of the humerus. So hopefully now you guys are kind of starting to figure out why those are named the way that they are named. Now, when I'm looking at it like this, that also gives me a great opportunity to show off this little depression right here. This depression is where the head of the radius fits to form the proximal radioulnar joint, okay, which is an important joint because that's what actually allows us to supinate and pronate our forearm. The radial head just sits in this notch and kind of rotates in it, so that's pretty neat. I'll get to that in just a second when I talk about the radius in greater detail. Now, just distal to that kind of coronoid process is a ulnar tuberosity, which is an attachment site for the biceps brachii muscle. We actually have a radial tuberosity on the radius that we'll talk about in a little bit. Okay. Distally, the ulna becomes much smaller than it was proximally. At the wrist, it's kind of the lesser of the two bones. The only thing that is really important to note there is this little extension, which is called the styloid process of the ulna, or just styloid process, which is a medial side of our wrist bump that can be felt right about where your watch would sit. Okay. Now, the easiest thing to do to tell right or left with regards to the ulna, in my opinion, is to determine where the radial notch is. Okay. Radial notch is where the radial head fits, which means that it always has to point in the direction of the radius. Now, we know that this is a medial bone, okay? So the radius, if this was a left, would not be on the medial side. This makes this a right bone because the radius, just happens to be here, would be just like that, and this would make it lateral on the thumb side and the ulna medial. Okay. Now, speaking of the radius is a lesser bone at the elbow and a more important, larger bone at the wrist. Okay, as you can see the difference in size, it's especially apparent when you look at pictures of it. Of the stuff to know about the radius, the most obvious will be its kind of disc-shaped head, kind of looks like a wheel or a tire, which is actually important because when we supinate and pronate, that's kind of what happens. It turns like a wheel or tire right in that radial notch. In actuality, the radial head doesn't really move when we supinate and pronate. What happens is we see distally the radius rotating around the ulna, and the ulna stays still and the radial head stays pretty well still, although it is still able to rotate, and that's due to a ligament that holds it in place. And so the radial head, very, very obvious structure, not apparent on any other bone. There's a big, very large bump that projects medially over towards the ulna. That is another one of those tuberosities. This one is known as the radial tuberosity, and is another place or site of attachment for the biceps brachii muscle. And then distally, we see another kind of extension of a forearm bone, and this too is known as the styloid process, and it can be felt on the thumb side right about where your watch would be sitting. So those are the two bones of the forearm. These both happen to be a right radius and ulna, and now you know why. Thank you.